Okay, thank you very much, Martin, for agreeing and telling us all about your planetary and Venus imaging. Thank you.
Great, thanks very much and welcome to everyone. I want to talk a little bit about my attempts at imaging the night side of Venus, and also talk a little bit about my interest in astronomy and how I got into astronomy. As you know, the planet Venus is shrouded in a very thick reflective cloud, and it's that makes the planet so brilliant in the night sky. But with the right setup and methods, you can actually see through the cloud and see the very surface of the planet. So this is a talk about how I managed to do that in the recent evening apparition. So, how does it all start? Well, for me, my father introduced me to the sky and told me the legends of the stars on evening walks. We had a pair of Zenith 70 by 50 binoculars, which we looked around the sky at the Pleiades and the Orion Nebula and things like that. And I found myself fascinated with the sky and awed by the vastness of it all when I looked up. In 1969, I got my first telescope. I've still got it in the garage. There it is, there's a picture of it. It was a 60 times with a 50mm lens that was stopped down to 10mm. So I never really saw much through it, except for one night, somehow, by a miracle, I managed to find the planet Saturn. This was in about 1971, and there it is, a perfect jewel, perfect yellow jewel that I saw with the rings, and I was hooked. So I used to dream of owning a proper telescope, and I'd spend hours poring over the Edmund scientific catalogue and the Fullerscopes catalogue, salivating over the telescopes in there. At the time, I lived at my parents' house, which is in North London, Finchley, and not too far away. You could take a bus ride, and I used to ogle through the round window at Fullerscopes there, and it was like looking into heaven itself. So I used to dream of owning a telescope like these 6 and 4 inch telescopes. The idea of owning a telescope of 8 or even 10 inch was just, you know, beyond imagination. So my first proper telescope I bought for £35, or my father bought for £35. It was a 3-inch refractor advertised in Exchange and Mart from a guy called Mr. Cook, who lived in Ealing, who seemed to advertise the same telescope week after week. And it was only later I realised that he was actually selling the same design of telescope, and he advertised for years. So I bought the 3-inch refractor and was absolutely delighted with it. I used it almost every clear night for several years in the early 70s. Observing from Finchley when you could see the Milky Way there. And I used to sketch the planets and many deep sky objects. And part of that sketching was used to pass my O-level astronomy, which I took on my own. I went to university in the late 70s, and unfortunately astronomy stopped then as other interests took priority. But here are some of my sketches from back then. Open clusters, nebulae, galaxies. You could see vague sort of shapes to them, quite a lot of planetary detail. Again, I still own that telescope. There's a sketch of Jupiter and a sketch of Saturn there, and that's started me on my path, my particular interest in the planets. So 1989, I went on a short weekend away to Donegal in the north part of Ireland, very dark skies, and it was the time of the appearance of Comet Austin, and I crept out of the house in the early hours to try and find the comet, which I never found, but just the excitement of it all and being in a strange place out in the dark countryside brought it all back, and I was hooked again. So in the intervening period, while I'd been away, the Dobsonian Revolution had happened. big scopes, big aperture scopes were available at much lower cost, easily portable, and I bought a 10-inch dark star Dobsonian reflector from Telescope House, which was on the Farringdon Road then, and was very pleased with that, but immediately started improving it, adding new features and improving the performance. So with that telescope, that was over 3 times the aperture of the 3-inch, loads more light, 10 times the amount of light, 3 times the resolution. You can see loads more detail in the planets, loads more detail in deep sky objects. So here are some of my sketches back then. You can really start to pick out detail. You can see spiral structure in the Whirlpool galaxy, dust lanes in edge-on galaxies, and as I said, loads more planetary detail. But I'd got the bug. And in 1993, I decided I needed to somehow to get a much bigger scope. And my specific target then was to see more detail in deep sky objects. And I wanted a scope that would disassemble, fit in the back of my car, and yet be quick and easy to assemble at my observing location. So I lived at the time in Colindale, in North London, right next to the Edgware Road. Terrible skies, no real garden. So the idea would be pack it in the car, drive somewhere dark, observe with it. So after 3 years of design work and building this in a small bedroom, my telescope Fossil Light, which is an 18-inch Dobsonian mounted telescope, was ready for first light. So here it is, packed into the back of my Astra estate, ready to go away to Kelling Heath. Well, actually, back then the Equinox Sky Camp, which was at Dower House, all packed up to go away there. So I'd go there once a year, go to Pembrokeshire, Exmoor, Mid Wales, various trips with Wallace. So as Rachel mentioned, yes, I'm the Treasurer and Membership Secretary of the West London Astronomical Society, and I've been there about 25 years now, and often we have trips once or twice a year away to dark sky places, and this is the telescope I take with me. Here we are at Dower House, the early days of the Equinox Star Party with Fossil Light. It's a camping, observing weekend, tremendous fun, great social occasion, and with quite a good record of clear skies. So here are some sketches with the 18-inch scope there. You can now see much more detail. Actually, the one in the middle is from is not with the 18-inch. That's with 25-inch from Tenerife. So it's cheating a bit, but you can see M101, M106 spiral structure there. Not easy, but you can see it in the right conditions. Here's some emission nebula, Crescent Nebula, Thor's Helmet in Canis Major, from the Chilterns. Sketch of one of my more ambitious sketches. This is M31, showing dust lanes there, quite a large object, lots of fields to capture that, quite a difficult object to draw. And then probably my most ambitious drawing to date, which is the Veil Nebula, done in 2008 and 2009 from Kelling Heath. So more though, this is one type of object that I'm particularly interested in, and that's galaxy clusters. So love drawing things like Copeland's septet or Stephan's quintet, small clusters, tightly packed clusters of galaxies. So in 2001, I decided to build a smaller Dobsonian telescope that would be easier to use in the garden, that I'd use more regularly, because the big scope was quite a chore to put up, and I would reserve that for going away places. But in the back garden, I thought, oh, well, I need a telescope to do a bit more astronomy those times when I'm not away. So I managed to get hold of a very good David Hines 8 3/4 inch mirror set, and built it into this telescope. Again, a Dobsonian, and designed to give good planetary views. So here we are, observing locations. So I live in St Albans. Just about see the Milky Way on clear summer nights, particularly transparent summer nights. I get good views south and west, not too bad north, not so good in the east. Then in 2005, I built an equatorial tracking platform. The idea was to do some planetary imaging. So I don't know if people are familiar with these platforms. Anything you put on the platform, if you put a tripod on there or a telescope, it will track the stars. So it's a nice combination in that you can do equatorial tracking, but you still have the human up, down, left, right movement of the Dobsonian telescope. So for me, it's the perfect combination. So I started doing some planetary imaging, and this is one of my first images. This is Mars, showing volcanoes on the right-hand side there. I don't know if you can see my cursor, Dave. Can you?
Yep, sorry, it took me a while to unmute.
Yeah.
Yes, I can see it.
Yeah, okay, good. So Tharsis volcanoes there, punching through the morning mists there. Lovely. This is my favourite view of Mars here. These tremendous finger-like albedo features in the southern part of the planet. And that was a particularly good apparition, plenty of clear nights, and it enabled me to use those images and create an albedo map of the planet there. So lots of features. I went through and labelled them all. Amazing what you can see from your back garden with an 8 3/4 inch. So in 2013, I thought I need a step up in aperture. So I started using the 18 inch on the equatorial platform. I had built the equatorial platform to take the weight of the 18 inch, but always been too fearful of actually trying it out in case it didn't work. 2013, I thought, right, I'm going to try it. So I did, and it worked, and it's worked beautifully. And that's the telescope I generally use for planetary imaging. At night time, if I'm doing daytime stuff, I tend to use the 8 3/4, say for Mercury and some of my Venus imaging. So that's my best ever view of Mars in 2014 at an altitude of 35 degrees. It's one of my better images of Jupiter in 2017. And here's Saturn. So that's just at an altitude of 16 degrees last September. So that is an infrared color combination. So I've used the infrared channel, 642 nanometer infrared channel, combine that with a color image. But you can see the polar hexagon there, and hints of the Encke division at the very edge here and here. This is the planet Uranus from last December, December the 3rd, a night of very good seeing. So again in infrared, and with the satellites from a separate exposure, which worked very well. Also do some ISS imaging. So this is hand tracked with the 8 3/4 inch there, and enjoy doing that. It's quite different. Very quick, 3 minutes and the session is done, and then the following evening process it and pick out the best frames and stack the ones you can. So let's wind on now. So this is a talk about imaging the night side of Venus. So this has been a really excellent apparition of Venus. The 2020 apparition was one of the best for 8 years. So Venus goes through a repeat cycle. So it has 5 evening apparitions in an 8-year period, and then it starts virtually back at the beginning again. So this is one of the good evening apparitions, with Venus high in the sky in the evening, seemed to hang around for months, bright and high. Tremendous apparition. A plug for this particular website. This is nakedeyeplanets.com by Martin Powell. It's a superb website, loads of information about the apparitions, each of the apparitions, and with sketches like this, beautiful sketches showing the path of the planet at 30 minutes after sunset. So I did my usual imaging. I imaged in infrared with the 444mm and the 222mm. So here are some infrared images. But I also, so I used my 18-inch. That's the big scope there on the equatorial platform. So that's it, taking the images you've just seen in, well, close to sunset really. Soon as I could see it, it's quite high in the sky. It's so bright. In the infrared, you don't need the sun to be down to capture good images. And here's a particularly nice one from the 19th of May with an 807nm infrared filter to help steady the views. So I also image in the ultraviolet light, and ultraviolet allows you to see cloud detail, to pull out cloud detail if the conditions are good. And here are some images, and that's one of my better ones from the 24th of April. So this apparition being so good, I wondered about attempting something I thought about for a while, and that's to image the night side of Venus in the infrared. So Richard McKim from the VA had written an article in the October 2017 BAA journal. He reported on efforts by Anthony Wesley and Phil Miles in Australia to capture the night side of Venus in infrared light and capture surface features. So they had seen surface features, but they'd also spotted seen a brighter spot, which it was suggested might be volcanic in origin, and so follow-up observations were very much encouraged. So here's Anthony and Phil with Phil's 508mm Newtonian, and below that you see the overexposed day side and the night side, and it may just look like noise to you, but these darker patches are cooler areas on the surface of the planet. So you can see here, this is an altimetry map of Venus. You've got a feature here which is Aphrodite, and you can see this same feature here. So this is match for match in longitude. You can see 2 spots there, these 2 spots here, this spot here is here, and you can see this brighter feature here which just sits here, and that was thought to possibly be volcanic. So how can you see the surface of Venus when it's covered in thick cloud? Well, here we have a plot of the emission spectrum of the night side of Venus. So the darker side, not in sunlight, and you can see a number of peaks there. And in this range down here, 96% of that light is thermal emission from the surface. And the cloud is relatively transparent, those wavelengths, and that allows you to see variations in the temperature of the surface, higher areas being cooler and lower areas being warmer. Other wavelengths around here, 1.27 microns here, that's sky glow, so oxygen sky glow, and other peaks relate to carbon dioxide and water and things like that. But this is the area we're interested in. So what you need is a filter that cuts out as much of the other stuff as possible and allows you to see this peak. So I'd been put off attempting the challenge. I knew that specialist filters were needed, and Wesley and Miles used a filter pair to define a narrow band pass at around 1,000 nanometers. But that was about 600, 700 pounds for the filter pair, which was way out of my pocket. Then talking to a couple of the BA section directors, David Arditi and Paul Abel, David suggested that the BA might, if I applied, cover the cost of the specialised filters. They've got a Harold Ridley grant scheme, so I applied for that, and very pleased and very grateful to the BAA that my application was successful. And just as I was about to place my order for the 2 filters, Anthony Wesley and Phil Miles told me that a new filter was on the market, much cheaper. So this is about £300, and it's a single filter available from Edmund's Optics. So 1,000 nanometers with a 25 nanometer band pass. So perfect for the application. So the first thing to do was to mount it up. It's not threaded, it's just a simple 25 millimeter circular metal ring. So I had to mount it up, put it in an old filter holder, and put it in a baffle tube, because I was going to be imaging in bright skies, something that was quite dim. I needed to reduce light scatter as much as possible. So I built a tube with circular black baffles in it so that I could only see the secondary mirror, only look at the secondary mirror, no light coming in from the sides. So silicon-based cameras are very insensitive at around 1,000 nanometers. So way down around about 5% of their peak efficiency. So to see the night side emission, which was faint anyway, long exposures would be needed. And you've got the problem that the day side, much, much brighter, and that could swamp the dim light from the night side. So on the screen there, you see here the view, the preview screen of my laptop while I'm capturing there at 1,000 nanometers. You can see the overexposed crescent if it's correctly exposed. So here's an exposure taken that night, correctly exposed. So you can see it's a much slimmer thing altogether. So this bloats and swells and puts glare into the field. So it does cause issues. But in the right conditions, when the sky darkens a little and you bump up the gamma on the preview screen, you can actually see hints of the night side here. So you've got the bright crescent, you've got the night side, you've got my diffraction spikes because it's a Newtonian with vanes holding the secondary mirror in place. You get diffraction from that. It's very fortunate that the orientation of those vanes and the orientation of Venus just couldn't have been better. It could have been that the diffraction spikes went right through the middle of the night side. Just fortunate it didn't. I wouldn't have been able to do anything about it because the tube cannot be rotated. But you can see how noisy and how dim the night side is. So before starting, I thought the main challenge with this imaging would be the overwhelming brightness of the day side swamping the night side. But really the big difficulty is the dimness of the night side. So I needed as much light as possible. So I needed long exposure times, many tens of minutes. I also used the telescope at prime focus, so short f ratio, which is 4.4 for my scope, and the big aperture really helping. So let's see if this runs. So this is a video. This is one of the best nights that I had, which is about a month before inferior conjunction, 5th of May, 3-minute video. And these are 200 millisecond exposures with sort of a moderate gain. And I've bumped up the gamma and the gain just for the video for display purposes. So hopefully you can see that. Can you see that okay, Dave?
Yep, that's great.
Okay, good. So you can see the night side there. Often though, the sky, you need a little bit of light in the sky, but you don't want it too bright, and then you can see it on the screen. Okay, so I want to talk a little bit about the problems of imaging the night side. So a little bit of academic stuff here. I want to talk about shot noise. So as I said, the night side is very noisy, and you need to capture for long periods to improve the signal to noise. So here's an image taken of the moon rising over the Alps in Switzerland. Beautiful view to the naked eye. Very disappointing with an iPhone there, and you can see all this noise in the background. Completely lost, you know, the beauty of the whole scene. And that is shot noise. So let's talk a bit about shot noise. Just to warn you, there are a couple of slides now without any pictures. So hopefully it won't grit your teeth to get through these couple of slides and then back onto some pictures. But I want to talk a little more about shot noise and what it is. So light's got a dual nature. In some circumstances, it's best thought of as a wave. In other circumstances, it's best to regard it as a particle. So in low light conditions, light's best considered light particles, and it arrives in discrete units called photons. Now they arrive at random intervals, and the number collected by each pixel varies because they arrive at random intervals. And so one pixel in a given amount of time, even though the scene might be totally uniform, will have a different number of photons gathered in that pixel compared to the pixel next to it. So you get variation in the signal as a result, random variation, and that is shot noise, quite simple. Now, how much is that variation? Well, it is the square root of the number of photons captured. So if you've got 100 photons, the variation in that signal will be 10. Square root of 10 of 100 is 10. So it will vary from 95 to 105, typically. Now, the greater the number of photons, the greater the variation, but the better the signal to noise. Well, what do I mean by that? So as I said, 100 photons, shot noise is 10. So the ratio of the signal, which is 100 photons to 10 photons, is 10 to 1. If you have 10,000 photons, so 100 times the number, square root of 10,000 is 100. So you've got 10 times the amount of noise, but the signal is 100 times bigger. So the ratio is much better. It's now 100 to 1. So the noise has gone up, but the signal's gone up more. So that's much better. So to reduce the impact of noise, you increase the amount of light gathered. So with planetary imaging, if you want to increase the amount of photons gathered, you don't expose for longer. You do need to gather more light, but the way to do it is to gather more exposures. So if you expose for a long time, because you're working at the resolving power of the telescope, that will lead to blurring, because the planet will be in a constant state of agitation due to the atmosphere. You're working at very fine resolutions, you'll get smearing. You can't do that, although you would do it with deep sky imaging. You have to keep the exposure short. So to increase the amount of accumulated light, you gather more frames. So that's the key thing about planetary imaging, is the final image is made up of lots of short exposures which aren't blurred, and they add together to make one long exposure. So what matters is the accumulated exposure time. So here we are. Here's a real world example on Jupiter. 1 frame, 10 frames added together. You can see how much the noise is reduced, and 100 frames, you can see 10 times less noise, and you can start to see, you know, the detail come out, which is completely lost in the first image. So you've got a dim night side, which requires long exposures to improve the signal to noise. But with imaging the night side, you've also got something else to contend with, and that's the brightness of the sky. You can't just image at any time of the day if you're trying to capture the night side. And that's because the sky, the brightness of the sky, overwhelms the night side and leads to noise in itself. So you can see here's me imaging, close to imaging the night side, and you can see how bright the sky is. So here is a aligned and stacked image in registacks. So here we are, we've sharpened it. This is from the 5th of May, and here the planet was 26 degrees high. This was 20 minutes after sunset, and this is what I've got here. And if you tweak it and bump up gamma, so at the moment I haven't done that and I haven't stretched it at all, hey bingo, the night side appears, and you can see these darker patches on there, which could be noise, they might be something real. You can see the diffraction vane, and here was actually a star that, as I took videos, moved through the field. I think it was about 8th magnitude star. However, if you do the same thing but 16 minutes earlier, when the sky was significantly brighter, that's what you get. So going from that to that, the dark patches are there, but it's much noisier. So all the conditions are the same, the capture conditions, same exposure time, the same gain and everything. So why is that much noisier than the previous one? Hopefully this slide will help explain. So here we have a schematic showing the night side of Venus. We've got a grey level of 25. We know that the noise level, the shot noise, will be root of that. So we've got 5 levels of noise on a signal of 25. So a 5:1 signal to noise ratio, and you've got a black sky. Increase the sky brightness a bit. So the sky is 16. Root of 16 is 4. So you've got a noise of 4. Obviously that sky isn't just in the background, it's over the planet as well. So it brightens the night side. So the night side now is 25 plus 16. The root of that is 6.4. So you can see the noise has gone up. A much brighter sky of 64, 25 plus 64, 9.4. So you can see that the noise level here is going up. So even if you subtract this off and take away 64 from the background, you're taking it away evenly, you're not taking the noise away. So you end up with a much noisier image. So here are some of my first attempts at imaging the night side. And at the time I used 2 cameras. So with the money that was saved on the single filter rather than the double filter, I bought a CS3, a point grey CS3 camera, because this was the same camera that Wesley and Miles used, so I knew it was going to work. I had some problems with the camera I was intending to use. I'll show you an image at the end if we've got time, with multiple reflections inside that camera, which is an ASI 290 camera. Very good in the infrared, but hopeless because of this secondary reflection issue. So BAE were kind enough to approve that I could buy the camera. So I bought this camera, I used that. But I also tried my ASI 174, which I thought would be not sensitive enough and the pixels too large. But actually it turned out really quite well. This camera's got 3.5 micron pixels, I think, and this camera's got 5.86 micron pixels. But what I did see was same dark areas with both cameras. And then the following day, dark areas here and dark areas here, but they didn't seem to sort of line up. But these were very noisy. As Venus got bigger, I managed to get better views. And you can see here, my method was improving, clearer views here, less noise. You can see 2 dark areas here and same 2 dark areas here. So I thought I was onto something, and I was actually seeing something real. So here we see the results of combining the best 90% of 7 3-minute videos. So this is 19 minutes accumulated exposure from the 5th of May. And you can see these dark areas here and this H-shaped region here. And those are real cooler areas of the planet's surface. You are looking at the surface of Venus. So WinJupos, which is a popular program for planetary images, has got a great feature which allows you to de-rotate the planet or change the appearance of the planet to a different time. And you can use that and combine images from different days, even though the planet is rotated in between, to one common day and stack them. This is a new feature that Anthony Wesley persuaded Grisha Hand to add to WinJupos. Perfect timing, because with that feature added, I was able to add days together, and that helps improve the signal to noise. So we see here data combined from the 2nd, the 5th, the 9th and the 14th of May, with 72 minutes of accumulated exposure time. So that gives a much smoother image with better signal to noise. Here's another one with 44 minutes accumulated exposure, showing this H-shaped region here. It's moved around a bit. The dark area, the 2 dark areas have moved closer to the limb there. And then going back in time, back to April, so before the first one, you can see this vague H-shaped region here, and again the 2 regions. So what you can do, using WinJupos, is to unwrap the planet, combine them and produce a map. So that's what I've done here. And I've got that set against a Magellan probe altimetry map for the planet. And you can see this similar shaped region here, which is Phoebe Regio. You've got this double region here, which is Beta Regio, corresponds with this here, Asteria Regio, and Ultran Regio. So these are known features on the planet. People have imaged them before. I'm not imaging them for the first time. And quite bizarrely, I found out that at every inferior conjunction in the evening, you see one set of features, and in the morning it's rotated a bit more and you see this area. And apparition after apparition, that repeats. And it's not that it's tidally locked with the Earth or anything. It is bizarrely just coincidence. Over thousands of years it does change, so it's not something that's long term. But yeah, if you work it out, you find that every inferior conjunction and every superior conjunction, the same face of Venus is facing the Earth. So you can't think, oh well, the next apparition I want to see this part of the planet, and then the time after that I'll see this part, and I'll be able to produce a whole map. You're stuck with seeing the same face apparition after apparition in the evening, and if you want to see a different face, you've got to image in the morning. So later on the apparition, I was able to extend the viewing window a few more days. The lockdown was sort of coming to an end. Wicks opened up just in time for me to buy some concrete blocks and elevate the scope and to be able to see over the neighbour's fence. Venus was low now. It was getting close to the sun. The sky was quite bright. Wasn't really as good as a month before inferior conjunction. So this is like in the middle of May. So my last session was on the 20th of May. That was 13 days before inferior conjunction, and Venus just 20 degrees from the sun. So here we have, I don't know how well this comes across as a video. So this is an animated video that I've put together for the different days. Hopefully you'll see these darker areas moving across the planet as the day slowly progresses. So that's the combination of all those days of observation.
Looks good to me, Martin.
Good. So quite pleased with the whole thing overall. Keen to try it again. Better cameras are coming onto the market. There's a new camera from ASI and QHY with a much more infrared sensitive chip in it, a Sony 462. It's only available in colour. ZWO have just brought out the camera. I've got one to test. It is about, well, on the plots for it, it's about 5 times the sensitivity of this camera at 1,000 nanometers, which is tremendous. So instead of about 5 to 8%, it's supposed to be 40% efficient at those wavelengths, which would be tremendous. So I want to try that out, but I do worry that it will suffer from the same reflection issues as some of the other Sony chips. So since then, I've been continue to image Venus. Here we are from the 1st of June. So this wasn't 1,000 nanometer, this was color, just color camera imaging with Venus just 3.3 degrees from the sun. Never got to see it as a complete circle. Don't try this at home unless you really know what you're doing. So there we are, you can see I had to use a tethered screen there to block the sun. shield the sun. I'm just looking over the top of the screen there. The following day, the pole just would not have been high enough to cover the sun and allow me to image the planet. So I had to give up there 2 days before inferior conjunction. But I managed to get that, which I'm quite pleased with, which is getting towards a full circle. If you do want to see some more images, there's my website, skyinspector.co.uk. I'm rebuilding the site at the moment. The current hosting company is pulling the plug on it because the way it's built, it's a legacy product. They don't want to support it. So I'm rebuilding it, and my deadline is the end of the month. So end of the month, I'll switch over to my new website. All the addresses should be the same, but it'll be a new improved format. And just quickly, we've got a second. So here is views with my ASI 290 camera showing the secondary reflection issue. So you can see these horrible secondary reflections that just swamp the night side. So although it's nice and bright, it's just hopeless. And this is a backside illuminated chip, and I think there's probably buried reflective metallization or something in the chip itself. It rotates with the chip, it's orientated with the chip, orthogonal directions, and if you rotate the camera, they stay in the same left, right, up, down orientation. It also affects the ASI 178 and possibly the 224 MC camera. I've seen images as well also showing it. And it would be a shame if the 462, the new 462 chip shows it, but there is a chance. So hopefully you've enjoyed that. There's quite a lot of slides there. I've had to whiz through it a bit. I don't know if there are any questions.
Absolutely fascinating. Thanks, Martin. Absolutely brilliant to see your progress, how you started out and developed.
Thank you very much.
Yeah, at one point you didn't live too far from me in Colindale, because I lived
really?
that way for a few years till we moved up to this neck of the woods. So
okay.
They've had some great views through the big Dobbo up at the Parador then, is it? Is that where you did your...
Yeah, yes. Yeah, the 25-inch at the Parador. Yeah, tremendous site.
Fantastic.
Absolutely.
Yeah, I've had a few, I think 3 trips I had up there.
Yeah.
Yeah, good stuff. Right. Anybody got any questions for Martin?
Early in the talk, you had some very good photographs of the main planets there, you know, Venus, Jupiter, etc.
Yes.
And what was the exposure? Because the pictures were so clear. What was the exposure for that, or what was the sort of stacking you used, or how many?
It would vary depending on what the subject was. They're all short exposures stacked, you know, many thousands. You're limited on some of the planets because the planet is rotating, but WinJupos allows you to extend that window to sort of 15 minutes. Saturn and Mars, you can probably stretch that a bit further, but the main problem is seeing. So that would mean that you would be rejecting most of the frames that you gather would be disturbed by atmospheric movement, and so I might stack 10%, 20%, possibly 30% of the images that I've gathered.
Mm-hmm. Okay, thanks.
Okay.
Lovely pictures.
Thank you.
Martin, Colin Daly here from up in Wakefield.
Hi,
I'm
Colin.
Just thinking about some of the work that you're doing, and the Soho Observatory sprung to mind. Now, when they are imaging the sun, they put a disk in front of the sun to minimise the sun's sort of strength.
Yes.
Is it possible to do anything similar to that, to obscure the bright side of Venus when you're imaging, just so that you're actually imaging then the night side, so to speak? Yeah,
you could paint a crescent onto the chip or have some sort of, you'd have to have rather than the first focus being on the chip, you'd have to have come to focus and then have something at the focal plane and then refocus it again. But with the tracking platform I've got, you just haven't got that ability to hold the tracking that steady that you'd be able to keep it bang on position. And as I said, actually, the bright crescent was less of an issue than I thought it would be. I thought that would be the major issue, would be the light from the crescent, and it wasn't. The main issue is just the dimness of the night side against the bright sky. You have to, you can't image it in total darkness because it's just too low in the sky. And that's actually the best time, is after the sky's gone properly dark, but Venus is still high. So you would imagine that as Venus approaches the sun, you know, gets closer to inferior conjunction, the planet will be larger and you'd get better images, but that isn't the case. The best time seems to be about a month before.
Thanks for that, Martin. Cheers.
Okay.
Yeah,
Anybody else?
Yeah, Martin, a question, please. Fascinating talk and superb presentation. Thanks
Thank you
for doing that.
Thank you.
I was intrigued by, I think, one of the earliest slides. You showed a screenshot of Registax, I think.
Yes.
Is that the only method that you use to sharpen using wavelets, or do you do any other sharpening in any other apps at all?
Yeah, so my first pass is always with Registax, and sometimes that's enough. So I only ever use the first layer, the top level there. Sometimes I use linked, the linked feature there, and I just move the slider to 100%, and I would then vary the sharpen level and the denoise level. Might add a bit of gamma and brighten it, but that would be my first pass. But if you are combining images in WinJupos, so you might have 3 or 4 videos, all of which yield good results. You'd process each of them using Registax, but actually when you combine the 4 of them, you've got good signal to noise, and you can take it further. So I use a program called Astra Image Deconvolution. It's available as a plugin for Photoshop. I don't use Photoshop, I use PaintShop Pro, which is much, much cheaper. It's about £40 or something. So it's available as a plugin. The same plugin that's used for Photoshop can be used for PaintShop Pro. Tremendous plugin, and that allows you to do some deconvolution, and that pulls out more detail. So that's particularly useful once you've combined using the derotate function in WinJupos to you know, give it that extra bit of punch and put out some fine detail. Works really well on Mars.
Okay, that's super. Thank you.
Okay.
Yeah, I think the thing with wavelets, everybody's got their own way of doing things. So everybody you see has got a different way of adjusting those.
Yes, it's very much personal preference, really, and developing your own methods. I like to keep it simple. Just use the top layer, Gaussian, slider at 100%, and then just change the sharpen. And you know, if it can't take it, it can't take it. I'm very averse to over processing. I like to keep things aesthetic, looking good.
Yeah.
Even if you're not actually pulling out quite the detail that you could if you pushed it a bit further.
Yeah. You see so many out there that have been over processed. It drives me mad.
Yeah, absolutely. Yeah.
Coming in, if I may, Martin, any tips
Sure.
on a newbie like me that wants to do Saturn and Jupiter, 8-inch telescope, DLSR and a ASI 190, I think it is. Any pointers welcome, please?
Yes, big thing at the moment. So for Jupiter and Saturn coming around, coming into opposition, if you are interested in getting good images, you really need to get an atmospheric dispersion corrector. So you will get horrible rainbow fringing on both those planets if you try imaging them. Atmospheric dispersion corrector costs just over £100, makes a massive difference to what you'll see. It really will.
Yeah, I did demonstrate very quickly before our speaker turned up last week. But we've got a spare day on the 21st of July. I know that's slightly late for the opposition of Jupiter, isn't it? But we'll pencil in planetary imaging for that, and I'll go through some of what I do, if that's okay. Yeah, and I'll show you what I do to take my images and process them. Yeah.
And
which probably be a little bit different to what you do, but yeah.
And do you use an atmospheric dispersion corrector?
I do, yeah.
Yeah. It's a necessity, really, for
it is. With them being so low down.
Yeah, absolutely, yeah. I mean, without an atmospheric dispersion corrector, that picture of Saturn would have been horrible.
Yeah.
And it's transformational, it really is. So get yourself one of those. They used to be, £300 to £400, but now ZWO and other Chinese companies have got in on the act. Prices come right down, so you can pick one up for the price of a premium eyepiece. But tremendous, and that's probably the most popular page on my website. Is my page about atmospheric dispersion correctors. So go to skyinspector.co.uk. I've got a whole long page about atmospheric dispersion correctors there, if you want to know how they work.
Excellent. Okay. Anybody else?
Well, I'm going to slide in another question, if I may.
Sure, yeah. Go ahead.
What will the James Watt telescope see? My goodness me, if you're shooting through the atmosphere, do you think the James Watt is going to discover something on Venus? Your thoughts?
I wouldn't have thought they'd be looking at the planets. Way beyond that. But yeah, I mean, I'm sure in the same way as Hubble was transformational, the James Watt telescope will see some amazing stuff in the far reaches of the universe.
Yeah, the James,
really exciting.
Yeah, the James Webb telescope will be looking at asteroids and things like that, but I don't think it's going to be looking at the planets because it doesn't image in visible light. It's infrared mainly. It works in, so it's going to be looking at asteroids in the solar system. I didn't realise it did that until I went to Summit last year. But it's going to be looking at remote galaxies as well as things way off that are redshifted into the infrared that that Hubble can't see at the moment. So it's going to be really exciting once it gets launched.
Yeah.
Okay, but no more questions? Well, again, thanks so much, Martin, for a fantastic talk, showing what you've got to do with your planets, and what you've done with Venus is really inspiring. So,
Thank you very much. Thanks for inviting me.
Absolutely.
Nice to see that you started, like me, looking through Fuller Scope's catalogue at all those telescopes you really could not afford at the time.
Yeah.
No.
It's fantastic the way the hobby's changed now, so that ordinary people like us can afford these things.
Yeah, I had the same catalogue that you were showing up.
Oh, did you?
Yeah, all the memories flooded back.
Yeah. No, I've still got it. It's incredible. Yeah.
Oh, you're lucky.
Flipping through it now, and the Edmund's catalogue.
Yeah.
It's like as if I only looked at them yesterday. Even though I haven't looked at them for sort of 40 years.
Yeah.
Having a look at those now. Yeah, it's amazing.
Packed full of stuff, weren't they?
Yeah.
I had the same telescope as your first telescope as well.
Oh, did you?
Yes.
Did you see anything with it?
mainly the moon. I was 9, I think, when I got my first telescope. So
yeah.
it's
yeah, it's a single lens, isn't it? It's not.
Yeah.
It wasn't even apochromatic.
No.
It was a single plastic lens, stopped down to 10 millimeters. So it's amazing it even showed the rings of Saturn, but it did, and that actually that was more inspiring than views with binoculars. I know people say, it's probably heretical to say it, but actually a view through a telescope for me meant much more, even though it was a single object, than views through my father's binoculars of the night sky. It was that really pushed the switch for me, just seeing that view of Saturn and the rings, and just absolutely perfect.
I was fully expecting to see Neil Armstrong when I got my telescope at 9 years old. So
I'm sure, yeah.
So learned a lot since then.
Yeah, I'm interested to try it on Saturn. I think as an experiment, I would try it on Saturn with a webcam on there and see really what it does look like.
Retro meets 21st century.
Yeah.
Fantastic. Yeah.
So I
started with Tascos. There you go.
Oh yes.
But they did inspire me to keep going. So yeah.
Yeah. Yes, great.
Yeah, that was my first view of Saturn, was through my Tasco, and the only reason I knew it was Saturn was that the distorted image was in a slightly different direction to the distorted stars. So
right.
This is different. And I
inferred the rings, yeah. So I should say I've got a Twitter handle which is @SkyInspector, not surprisingly. So any images that I take, I will post on there. So do feel free to follow me if you wish, and you can see all my latest images on there.
Yeah, well worth following. Yeah. Good. So anybody want to chip something in before we finish?
No, just say it's been a fantastic talk. Really enjoyed it.
Good. Glad you've enjoyed it. Thank you very much.
Thank you.
Excellent. Okay, all right. Thanks everybody for coming in again, making it the success it always has been. And thanks, Martin, for an absolutely fantastic talk and showing some of your images.
Yeah.
Thank you very much.
Okay, excellent.
Take care.
Okay, right.
Bye.
Thank you for that.
Okay.
Bye.
You know what I'm going to
Next
say?
week.
Keep safe, keep well, and keep looking up. Okay. See you, folks. See you on Thursday.
Bye.
Thursday, don't forget.
Bye.
Bye-bye.